All right, one theorem that is helpful when doing limits of sequences is if you take the limit as n goes to infinity of the absolute value of that ace of nth term and it equals 0, then that also means the limit of just the sequence would be 0. And this is helpful if you have a series that is alternating back and forth between the positive and negative. So let's look at an example here. Evaluate this limit as n goes to infinity of this one. Well, you can see having that -1 to the n term on top means this is going to bounce back and forth between positive and negative. But the nice thing is, if we put this in absolute value, meaning if we do limit as n goes to infinity of the absolute value of this sequence, this is going to help us out because we know, because this is always equal to -1 or +1, if we do the absolute value of both of those, they both equal 1. And so that limit right there would then just be equal to the limit as n approaches infinity of 1 over n. And n we don't need to have an absolute value around because remember over here we know n's going to be positive here, a positive number, so that is always going to be positive. Well, what does that end up equaling as you go to infinity? 0. And so we know that this would be that if this equals 0, that also then the limit as n goes to infinity of just this would also approach 0 and be convergent. So any of these alternating ones where they're going back and forth between positive and negative, take the absolute value to see what if the limit's going to be convergent or not.